Hello everybody and welcome back. Here we have it, the LOTMAXX SC-10. It's been printing for 2 days. I finished setting it up. I tested everything that there was to test about it. I gave it a lot of stuff to print. I checked that there is nothing loose with it. I messed with it a bit and now we're going to look at the results. Here we go. So these are the test parts that I usually print with all the printers that I have, all the new printers. They're special benchmark tests that show how good, how bad, how much quality you get. It basically touches on most of the performance points that you're looking for in a 3D printer. And to put it short, this printer did really well. It does have some issues, but they're very, very small issues. There's nothing wrong with it. I had it printing for 2 solid days and everything was just fine. Nothing changes, nothing started rattling. It didn't go out of alignment. Everything was fine. So let's have a look at some of the prints and go through all of the things that they mean regarding to the printer, and yeah, let's just do that. Okay, so let's first start with the shell test. This here is a very simple shell. It consists of 1 layer and nothing more than that. It does have some indentations, it has some grooves, and what we now have to do, we need some measuring tools, and we're going to measure the thickness of the lines, which is going to tell us how true the printer is to the nozzle size. It also shows us if we have over extrusion or under extrusion, and the measurement of 0.4 millimeters almost perfectly here means that the 0.4 millimeter nozzle is absolutely true. We have almost no over extrusion, we have no under extrusion, and that is a really good value. We can measure the sizes and we should be getting exactly 20 millimeters across. We're slightly over that, but just a bit. And over here we should be seeing 40 millimeters to make sure that I don't squish it like so. And we're slightly below that, but this is actually fine. So it is quite normal for the print to shrink, and oops, going out of shot here. And if the print shrinks, it's due to the cooling of the filament. We actually expect it to shrink a little bit, and that builds up some tension, and that makes the prints really hard. Now, the grooves in here should be about 5 millimeters. I've already measured that, and no, that's not true, should it? Hey, this groove should be 4 millimeters, and we're at 3.92. It's fine. And this here should be 5 millimeters, and we're slightly above that. This is due to the thickness of the filament, and since we do have extrusion, it basically oozes over on one or the other side. We can have a look at the surfaces, and this is really hard because this surface is almost perfect. There's some very slight ringing visible in the top of the surface, but it's absolutely minute. And the edges here, well, they could be sharper, but that is due to the construction and due to the print speed. I don't overdo the speeds. I print this at about 30 millimeters per second, and the sharper the edges, the better. What you can see is this would be printed like this, and you can see that the edges for the y-axis to x-axis movements are not as sharp as the edges for the y-axis to x-axis movements. So switching from one to the other motor has some lag because we have a certain mass that we need to move, and before it actually starts moving we have to pump a little energy into the table and then it starts moving. And this makes these edges seem slightly round, and this is the case for all 3D printers, and this one is doing okay, but not great. The little notch over here, this is basically a movement that falls right around the jerk setting for the steppers. So this will actually be moved with just one step to the steppers. So this would show if you have excessive ringing, and then you would have a pattern forming on this surface. And this is present on the printer, but it is very, very minute. So first test passed. The second test is it's called an alignment test. Basically, all these lines that join are once touched coming from the left side and once from the right side. If there would have been any backlash in the 3D printer, it would become visible here. And you basically need a microscope to see it on this printer because it's almost not there. This is a really good print. But once again, we see some ringing in the surface here, but this is so minimal. This is a really good example. We do have some noise in here, which stems from the z-axis movement. Basically, the printhead has to stop for a very short time when the z-axis is moving, and this is actually visible in here. And although the z-axis is reasonably quick, apparently there is some noticeable oozing while it's stopped there. And this could be addressed, but it's not really necessary. Speaking of oozing, we have an oozing test, which would usually be showing a few hairs between the center and the sides, or the other parts here, and we see almost nothing here. There's a few hairlines over here, but it's very, very small, and this can't be cleaned off very easily, so there's almost no oozing on this printer. Well, another test that's passed. Yeah, then we have the benchy. This here is a 50% benchy. There is some slight stringing, but the overhangs look fine. The bridges also look fine. It's a pretty good example. Once again, test passed, not with flying colors, but pretty solid. Then we get to the stress block. Oops. This print basically exposes almost any weakness. We can see some stringing down here, also some remnants of stringing in the box. This here's a 90-degree box with a sloping head, This is basically the distances that the printer needs to go change from layer to layer, and you can see if the printer has any problems with it. So the last layer is a pretty massive bridge, and you can see that it did quite well. There is some separation here, which is due to it being a big bridge. We have an overhang test over here, which is a sloping overhead, and it doesn't have anything behind it, so the further you get out to the edges, the more difficult it gets for the printer. And the printer failed for like the last 6 or 7 layers, and that is pretty solid. Then we have boxes with overhangs, and this here is 45 degrees, 60 degrees, 75 degrees, held on both edges, so printer did fine there. Finally, we have single-sided overhangs, 45 degrees, 60 degrees, 75 degrees, and on 75 degrees we can see that the printer was struggling, but this is to be expected. I only have one printer that really gets this done right, and it's not the price range of this one, and it's completely different. So yeah, the stress block was a full success too. And it took me a while to get all of this set up, because the different blocks are also done with different slicers, and each slicer then shows what the pros and cons are, because some slicers, for example, won't do something like this because it's not a solid object. They would just tell you it's non-manifold and refuse to print. So, well, and all this stuff down here, I printed this on with a brim, and I had the bed heating off. The print bed coating, or the mat that sits on top of the heated print bed, is excellent. For standard PLA prints, you do not need bed heating. If you have bed heating, it works even better. It's really hard to get off. It's probably good enough to do ABS, but for ABS you would probably need a chamber for the printer anyway, and that complicates things. So I didn't try ABS. Now, if we look at the surface here, try to get this in focus, we can see some of the ringing effects on the surfaces here, and these ringing effects have something which I call the belt ring, and it is pretty hard to get rid of this. There's a vibration in the print head that is caused by the belt. So if you see the frequency of the ring in here, it is actually really easy to see that it is just the same as a piece of belt. So if I put a piece of belt on top of here and rotate this, you will see that I don't know if you can really see it. It's really hard to see on this light. You can actually see that the frequency of the ringing in the surface is exactly the same spacing as the belt. And yeah, that is one of the problems with these printers, and there's nothing that you can do against it but go for a really complicated X and Y axis construction, where all the rollers that guide the belt are basically only touching the backside of it. So very hard to do, and printers that we have right now don't really go against this. So yeah, so this is basically what we got for quality from the print. I am pretty impressed with the speed. It's a pretty quick mover. I did like the I did like the volume, the sound. It's not silent. The X and the Y axis are, once you manually move the Z axis, that stepper is pretty loud, just as loud as other steppers are on other printers. But the problem with the silent movement is that basically the fan is so loud that you're going to hear the fan before you hear the movement. And it's pretty hard to demonstrate this right now because the fan just has this, I would call it annoying whine. And it's just, you still hear the printer, it's not completely silent. You have the fan on the main board, you have the fan on the power supply, and you have the fan on the print head. And all of them make noise. And if it turns on the cooling fan for the print result, it becomes even louder. So it's not entirely silent. It is more silent than other printers, I'll give it that. But we're still part way away from completely silent. So let's turn it on and have a look at the software. Now, the LCD screen with the menu is pretty much excellent. The icons are really easy to read. The backlighting is yellow, the text is black, so it's really easy to read. The operation is pretty quickly. You can really go through this extremely fast. Responses are absolutely instantaneous, so that is really, really great. Some things in the software are, well, kind of odd. For example, if I turn on preheat for the extruder, for example, I give it some heat, it will start heating up pretty quickly. That is one thing which is also pretty much excellent. There's absolutely no overshoot on the heated print bed or the extruder heating. It just works. The odd thing is turning off the heater says close on the icon, which should probably be off. You can change the temperature in 10-degree steps or 1-degree steps. You can switch from the extruder to the heated print bed. It is all wonderfully easy and pretty simple to do. Now, something that is weird, I'll show that to you. I'll just have to get an SD card, because without an SD card that is not going to work. Let's put that SD card in there. Now if I go to the print menu and I look at the files on there, you can actually see that we have VFAT 8+3 file names. That is a bit, I don't know, late 80s, mid 90s. A lot of printers actually are capable of displaying the full file name. Apparently this one is not, which I think is kind of sad. Now the rest of the software is super easy. You go to print, you go to move, and everything will just do what it's supposed to do. The settings are very simple. There's nothing really to do. You have settings for stop and continue. You have settings for setting the fan speeds. You can turn all the motors off. You can change the language. There are some filament settings. what the preheat temperature should be. There is a load and an unload, and it's a nice set of tools in there. And as I said, it's really nice to work with it because it's so fast and it just responds so well. So let's go ahead and get the printer to print something so you can get a feel of what the sound is like, what the movement is like, all of that, and how long it takes for the printer to start a print and to heat the extruder up completely. All of those things are really nice. As I already said, I very much like the way the PIDs are set for the extruder and the heated print bed. They do heat up reasonably quick, but there's absolutely no overshoot, and they hold the temperature really, really well. And I quite like that. So let's start a print. We go for printing, we select a file, which is going to be a really, really big print. We confirm that we want to print this, and the printer goes through the setup phase, and you can already hear that the Z-axis is really, really loud, while the rest of the axes are completely silent. Also, the extruder stepper is pretty silent, and that's quite nice. So it's now starting the preheat cycle. We're starting out at about, I don't know, 35 to 40 degrees. And it's ramping up really quickly. We're already at 130-ish. Going for 140. $160. So while it's doing that, yeah, I did cut the cable ties that held the PTFE tube to the stepper, to the extruder cables, just so the bend of the PTFE was a little bit more natural. I did have a few issues with the filament binding up in there, and there was a lot of strain on the extruder stepper, and this improved it quite a bit. Now, the 3D printer itself is quite the nice thing, and it prints at a really good quality, and the size is also very nice. But I was wondering where the printer would be standing compared to other printers. If you're doing a comparison, what other printers are in the same price range, or what would we compare this to? And I had a really hard time doing that, because the printer is very modular. The whole print is very closed up. It's very clean, so it is also priced, we know that, somewhere between I don't know, $220 and $300. I saw it at Deal Extreme for I think 220 or something, and for about 300 on Amazon. So what is it that we have in between there? And I was actually thinking, if we compare it to something like the ANET ET3, not ET4, it is basically a lot better than that. It has a better controller, it has better software, it's silent. So I'd say it's better than that. Then we get to the TiVo Tarantula Pro, which is somewhere around that price point. Especially here in Europe, it's even a lot more expensive, and it's still, I think, a little bit above that. And then we get to printers like the Creality CR20, or maybe even the Anycubic Mega. It's hard to place this, but for all of the things that it offers, it's pretty reasonably priced. So I'm not going to really pass judgment on that. I just wanted to give this as a general location of where to put this printer. It's really solid. It has very little vibration. I mean, it's printing right now, you can hear the fans, but that's about it. So it's also very silent, as long as it doesn't move the Z-axis, which it almost never does in a print. And yeah, it's quite nice. So regarding materials, I used a different set of materials for this printer, which were first of all standard PLA. This year's Prima PLA. I use this for almost all my benchmark prints, just because I know exactly how it handles and how it works. I tried some TPU, which worked pretty well with this printer. But I suspected that it would, because the PTFE hose is really short, and I think you could even shorten it some more. And yeah, the print was really nice. Surface quality was good. The layer bind was excellent. So this is really, it's not breaking. So really good. And right now what I'm printing here is a special PLA, which is made from recycled material. And usually this stuff is pretty hard to print because it becomes very hard and brittle, and if you have under extrusion, or if you have too much tension when you're pulling it, this will just break off and it won't work out at all. So the printer also worked pretty good with this. I think if it manages to work with these materials, it can basically take anything you throw at it. I don't know how well it will work with NinjaFlex, but I don't have any anymore, so I don't know. I suppose it might work, but it might have some oozing problems because of the long length of the filament tube. And finally, the filament that came with the 3D printer. I didn't try this on my benchmark prints and with the printer itself, but I tried some others. But I did a test print with one of those spools, and that came out pretty well. I would actually say for filament that is included with the printer, this is actually really good. I've had a lot worse than that. So this brings us to the end of the review. Now, it's a hard thing to do. I don't want to really pass judgment on this printer because there's nothing that I can really compare it to. It does bring technology that was limited to the $400 plus range down to the $300 range and possibly below that. It prints very nicely. It is a complete package. It came with everything that I needed to get it running. It came with a lot of filament. It was probably the best packed printer that I've had all this year. And it's a really nice machine. It works out nicely. It handles materials well. It does have the big platform. It has a pretty good build height. The firmware is nice, really snappy, and so it's basically pretty much a perfect package the way it arrives. Is it worth the money? Yeah, probably. I haven't done a lot of printing with it, so I don't know what it's like in half a year or so. If the V-rollers hold up, if some of the screws come loose, or if the belts are bad. You never know that stuff. So I like the printer for what it is. I think it is a pretty good contender for bringing the price down and still having really good features. And well, all in all, it's just a really nice printer, and it prints really well, and I suppose that's what's important. So this was the review of the LOTMAXX SC-10 printer. I enjoy it, I really like it. It does have a few small issues, like it does seem to be susceptible to vibration. It is really silent, which is slightly marred by the loudness of the fans. It has good features like filament break detection and read zoom or continue capability. So a great printer. The price is good too. And I think that is, well, that's basically the best I can say about this printer. I like it. So thank you very much for watching, and bye-bye.